Hello and welcome to Manga's Consulting YouTube channel. This channel provides tutorials in all areas of language technologies from language learning through speech and language processing. Please like and subscribe to this channel and click the bell icon to get new video updates. Ace your coding interview. Longest common prefix. Write a function to find the longest common prefix string amongst an array of strings. If there is no common prefix, return an empty string. The goal of the problem is to identify the longest common prefix shared among a given array of strings. If such a prefix exists, it should be returned as the output. If not, an empty string should be provided instead. The input to the problem is a list of strings, such as flower, flow, flight. The expected output is the longest common prefix found among these strings, for example, FL. The solution begins by sorting the array of strings. Sorting ensures that lexicographically similar strings are positioned closer together, which simplifies the process of finding the common prefix. After sorting, the longest common prefix can only exist as a substring of the first and last strings in the sorted array. Next, the algorithm iterates over the characters of these two strings. It compares each character until a mismatch is encountered or the end of one of the strings is reached. This comparison identifies the exact portion of the strings that forms the common prefix. The code begins with input validation to ensure robustness. If the input list is empty, the function immediately returns an empty string, avoiding unnecessary computations and handling edge cases effectively. Next, the array of strings is sorted, which ensures that the lexicographically smallest and largest strings are positioned at the beginning and end of the sorted list, respectively. This step simplifies finding the longest common prefix. Finally, the comparison between the first and last strings is highly efficient. Instead of comparing every character in every string, the algorithm only examines the characters in these two strings, which reduces unnecessary comparisons and improves performance. The first step in the solution is to check if the input list of strings is empty. If the list is empty, there is no common prefix to find, so the function immediately returns an empty string. This ensures the algorithm handles edge cases effectively. The second step is to sort the array of strings. Sorting organizes the strings in lexicographical order, which helps in identifying common prefixes. For instance, an input like flight, flow, flower would be rearranged after sorting, making it easier to find the common prefix by comparing specific strings. After sorting the array, the next step is to identify the first and last strings in the sorted list. These two strings are key because the longest common prefix will always be a substring of these two strings. For example, if the sorted array is flight, flow, flower, the first string is flight, and the last string is flower. The following step involves comparing the characters of these two strings. Starting from the beginning, the algorithm increments an index to compare characters one by one. This continues until a mismatch is encountered or the end of one of the strings is reached. The comparison helps pinpoint the exact portion of the strings that constitutes the common prefix. Once the character comparison is complete, the final step is to extract the common prefix using string slicing. By slicing the first string up to the index where the mismatch occurred, the algorithm isolates the longest common prefix shared by the input strings. For instance, if the first string is flight and the last string is flower, the comparison stops at index I equals 2, where the characters begin to differ. Using slicing, the common prefix is extracted as FL, which is returned as the result. The time complexity analysis starts with the sorting step. Sorting the array of strings takes big O of n log n time, where n represents the number of strings in the input list. Sorting is the most computationally expensive operation in this algorithm. Next, the prefix comparison step has a time complexity of big of m, where m is the length of the shortest string in the array. This step involves comparing characters between the first and last strings, and the maximum number of comparisons is limited by the length of the shortest string. Overall, the sorting step dominates the complexity, so the total time complexity of the algorithm is big O of n log n. The space complexity analysis begins by examining the space usage of the algorithm. Since the sorting operation modifies the input array in place, it does not require any additional memory allocation beyond what is already used by the input. This results in a constant space requirement for sorting. The rest of the algorithm also operates efficiently in memory, only requiring a minimal amount of space for variables such as the index used in the comparison. No additional data structures are created that would increase memory usage significantly. Therefore, the overall space complexity of the algorithm is big O, 1, indicating that it uses constant extra space. Thank you for watching. Please comment, like and subscribe to this channel.